Hi everyone and welcome back to another video of EDU PICO series. In this part, we will learn to build a smart classroom. In this project, we will learn to integrate the gesture sensor to track students' movement when entering and leaving the room. The goal is to create a smart classroom that optimizes energy usage based on the number of occupants. To achieve that, we will program the relay to turn on and off a USB LED light stick based on the presence of students, as well as to program the DC motor fan to regulate the room's temperature according to the number of occupants. This is how it works. Swipe your hand from left to right above the gesture sensor to increase the number of students by 1. Swipe your hand from right to left to subtract the number of students by 1. The fan speed will increase by 20% for every one person entering the room. If there is one or more people in the room, the relay will activate, lighting up the LED light stick. If the room is empty, the relay will remain deactivated. Let's start writing the code for this activity. Line 1 to 4. The code imports the required libraries and modules to enable the required hardware components. Line 6 to 13. These lines initialize the I2C interface, the APDS sensor, PWM control for the DC motor, OLED display, and the relay. Line 15 to 16 enable gesture and proximity detection on the APDS sensor. Line 18 to 19 initialize variables for class capacity and current fan speed. Line 21 to 27, the OLED display is set up with an initial text, providing a baseline for the user to navigate when reading information relating to room capacity, light, and fan. Line 30 initializes class number and current speed as global variables, which enable their values to process across different classes to the handle gesture function. If local variables were used, their values would be reinitialized every time the function is called. Line 32 to 34 clear specific areas on the OLED display where information will be updated. It uses OLED fill rectangle to clear rectangles at a specified area. Line 35 retrieves gesture value from the APDS sensor, where 3 represents a right-to-left gesture and 4 represents a left-to-right gesture. Line 37 to 40. If gesture detected is equal to 3, the class number variable will reduce by 1, and if gesture 4 is detected, it increases the class number by 1. Line 42 to 44 adjust the fan speed, current speed based on the class capacity. For each person entered, the fan speed will increase by 20%. The motor instance throttle property is used to set the fan speed. The greater the number of people in the room, the faster the fan spins to ventilate the room. Line 46 controls the state of the relay based on the value of the class number. If class number is greater than 0, relay value will be set to true, turning the relay on. If class number is 0 or less, relay value will be set to false, turning the relay off. Line 47 updates the OLED display to show whether the relay is on or off. It uses a conditional expression, where if class number is greater than 0, the text is set to on. Otherwise, it's set to off. Line 49 creates a string class status that displays the current room capacity status. If class number is less than 5, the string shows the number of people in the room. If class number is 5 or more, the string displays full. Line 50 to 51 updates the OLED display to show the room capacity status. Line 53 to 55, the try block contains the main loop of the program. The while true loop ensures that the handle gesture function is continuously called. Line 57 to 59, the finally block is used for cleanup operations, which include resetting the OLED screen to its original state. Line 61 deinitializes the I2C interface. This is important for releasing the resources used by I2C before the program terminates. Well done completing the project of chapter 7, but we are not done with this chapter yet. In the next video, we have a bonus for you. We will build a Wi-Fi AP network. Thanks for watching, and I will see you in the next video.